Hey everybody. All right, let's go ahead and take a look at our review for topic 1 of our master check. This is going to be covering topics 3.1 through 3.3. In other words, pages 1, 2, and 3 of our notes. So let's go ahead and take a look at this and see how we can do. So the first one says, determine if the following scale factors represent enlargements or reductions. And this was pretty straightforward. Remember, what we said is if the scale factor is bigger than the number 1, so 1.1, 1.5, 6 point something, anything bigger than 1, we knew that represented an enlargement. And what we also knew is that it could never equal 1. You could never have a scale factor of 1 because that means the figure's not changing. Also, we can't have negative scale factors. Those don't exist either. So for our other section, we know that if k, I'm going to write this over here, if k is between 0 and 1, so it's not negative because that can't happen, but it's less than 1, that represents a reduction. And that's all we're looking at with these. Bigger than 1, enlargement, less than 1, reduction. So this first number right here says that we've got 1.02. That is clearly larger than 1, so we know it is an enlargement. On this one here, we've got 5/2. The easiest way to do fractions is if the top number is bigger than the bottom number, it's an enlargement. It's bigger than 1. But if the top number is smaller than the bottom number, it's less than 1, so it's a reduction. So in this case, since the top number is bigger, we know that the whole thing is bigger than 1. So we have an enlargement. And on this last one, we've got another fraction. And again, this top number in this case is less than the bottom number. So since the top number is smaller, this would represent a reduction. All right, for level 2, they're asking us to find the scale factor given the picture. Now, this one's a little bit different than our notes. In our notes, they told us that we had figure A and figure B. In this case, though, there's A, B, C, D, and A, B, C, D prime. Remember that we have to start at quadrilateral A, B, C, D. That's the pre-image, and the image, the after, I missed the A, is A prime, B prime, C prime, D prime. So we know that that's the new shape. That's our new shape that we've gotten. And if you remember, to find the scale factor, we always take the new divided by the old. So we need to find one side that represents the new shape and divide it by one side that represents the corresponding side of the old shape. So our new shape is going to be this green one here. I know it's not green on your paper, but it's green on here, so we can see it a little clearer. This one right here, that would represent our old shape. And you can see I just kind of counted it there. 1, let me actually let that go away. 1, 2, 3, 4, 5, 6. So I can see that this new shape has a length of 6 across the top. While the old shape, this blue one, has a length of 1, 2, 3, 4 across the top. So if I set up this formula, new divided by old, again, the B prime to the C prime is the new one, so the 6 goes on top, divided by the 4 on the bottom. And I could simplify that. I can see that I can divide both those things by 2. And if I do that, 6 divided by 2 is 3, 4 divided by 2 is 2. Oh, sorry, it cut off there. 2. So I can see that the scale factor is 3/2, which again makes sense because that's bigger than 1, so it should represent an enlargement, and that blue shape is definitely getting bigger to get to the green shape. For level 3, they gave us the coordinates, and they're asking us to determine the scale, they gave us the coordinates and the scale factor, and they're asking us to determine the new coordinates. So remember, what we do in this case is, since we have a scale factor that's represented by a fraction over here, 3/2, we are going to use the top number to multiply and the bottom number to divide. So multiply by 3, then divide by 2. And it doesn't matter what order we do that in. We can divide first if it makes more sense to do that to you, if it makes it easier. But in this case, for today, I'm just going to go through and multiply and then divide each individually. So the first one, I've got -2 multiplied by 3, and then divided by 2. -2 times 3 is -6, and -6 divided by 2 is -3. And that's going to represent this number here, -3. The next one, I've got 5 multiplied by 3 divided by 2. That's going to give me 15 divided by 2. And since I can't really divide that by 2, you could give me the decimal. If you want to find the decimal, 7.5, you are welcome to do that. Or you can leave it as 15/2. I think that's a little less work, so let's just do that. We'll leave it as 15 halves. I'm going to do one more on here, and then we'll kind of just work the rest out in our heads. This next one, -8. Again, we're going to multiply by 3 and then divide by 2. So -8 multiplied by 3 is -24. Divided by 2 is -12. Like I said, we're running out of room here, so let's just kind of do the rest of them in our head. So for this -6, multiply it by +3, we get -18. And -18 divided by 2 is -9. Here I've got 7 multiplied by -3. That's going to give us 21. I keep saying -3, and I don't know why. It's a regular 3. 7 multiplied by 3 is going to be 21. 21 divided by 2, that doesn't divide very nicely, so let's leave it as a fraction, 21 halves. You could put 10.5, just like we said before. And for this last one, 10 multiplied by 3 is going to be 30. 30 divided by 2 is going to give us 15. And those would represent our new coordinates if we dilated by a scale factor of 3/2. All right, for level 4, we've got 2 triangles here, and they're asking us to determine what goes together. And you can see they gave us this similarity statement at the bottom that tells us these triangles are similar. So we know we're allowed to use proportions and ratios to solve these because this thing told us that it's okay to. What's important, though, is we got to make sure we match everything up where it goes. So I'm going to use my text marking. I'm going to use circles and squares here. So let me start with this 24. 24 is representing M to P. M and P, you can see down here, that represents our first 2 letters that I just underlined. So M and P is the first and the last letter. So it's going to go with Q and P. And if you can see Q is here and P is here, that's going to be then representing the 28. So my circle goes around the 28. So 28 and 24 get linked together. And I'm going to put a box here. I did it in different colors, so it makes it a little easier for you. But obviously, if you don't have different colors, you can just do a box like I did, box and circle. So this is side N to P. And N to P is these last 2 letters here. So it has to be with R to P. R to P is here. So RP is going to represent that 3x minus 9, which makes sense because it's the last thing we have. And we're going to go ahead and set up our proportion now. Again, make sure that you always do circle over circle, square over square, but that you're keeping it consistent. So in this case, I always want to put this triangle on the top. I always want to put this triangle on the bottom. So I'm going to have 24 over 28 is equal to, and then we're going to go square over square again, making sure we pick the left triangle first. So x plus 8 divided by 3x minus 9. Well, let's put some parentheses here on these 2 equations. So when I go and do my cross multiplication, 28 multiplied by x plus 8 gives us 28. And then, there we go, x plus 8 inside the parentheses equals. And then over here, we've got 24 multiplied by 3x minus 9. So 24. 3x minus 9. So we are going to have to do some distributing and bring that over here. Let me just kind of zoom in here. So 28 times x is going to be 28x. 28 times 8, pull out a calculator for that, that's a big number. 28 times 8 is going to give us 224 plus 224. Okay. And then on this side, we have that 24 times 3x. So 24 times 3 would give us 72. So we got 72x. And then 24 times -9. So 24 times -9 is going to give us -216 here. And we're just going to go ahead and solve that. So of my x's, I want to get rid of the 28x first because it's the smallest, and that will help us keep our x's positive. So 72 minus 28 gives us 44. Oop, I turned off my pen. There we go. Okay, so we're going to cancel out here, bring down our 224. This becomes 44x and bring down that minus 216. All right, next I'm going to take this negative 216 and add it to the other side. Cancel out here. And I end up with 224 plus 216 gives us 440. Okay, and then bring down this 44x. And that is going to divide kind of nice here. Divide by 44, divide by 44. And when I do this division, I end up getting 10 equals x. So we know what 10 is. But notice that's not what the question asked us. The question said find the length of PN and PR. So we're going to need to plug that 10 back in over here to where it goes. So PN represents this space right here. So if I plug 10 in there, I'm going to have 10 plus 8, which is 18. Give me 1 sec. From last semester?
From last semester.
Okay. Yeah.
All of a sudden disappeared.
Let me find out again, because I don't remember how to do it, but someone just helped someone with this. Let me ask them, and I can tell you later.
And then, it was whatever time that.
Okay. Cool. Yeah, that works.
Just let me know.
Yeah, will do. All right, sorry, there was someone at the door. So let's just pick up this video again. So we're gonna plug this 10 in. I plugged it in here. 10 plus 8 gave us 18. And in the bottom here, there is this 10 times 3 minus 9. So I've got 30 minus 9 equals 21. So those are my two answers. So PN is gonna be 18. PR is gonna be 21. There we go. All right, on to our last one. It says, determine if the following triangles are similar, and if so, by which similarity theorem. So automatically looking at this, one of the first things that I'm picking up on is there is three sides here on this little triangle. And obviously we got three sides on the big triangle as well. So I know that I'm thinking about this being probably side similarity, but I need to figure out how to prove that. So what I'm gonna look at here is I'm gonna look at this whole side here together. And if I see, so why I'm looking at the whole side together, let's talk about that, right? If I go and highlight this here, this 18 has to correspond with the other big triangle on the top, which represents this piece here. So I'm gonna need to add these two numbers together to figure out how long it is. So 6 plus 18 is 24. And so I know that the 18 is gonna correspond with the 24. And I know that the 6 is kind of irrelevant. We don't need it because that represents the length of this trapezoid shape here. And we don't really care about that. We just need the whole thing together. Likewise, on the bottom, I've got this 15 here. And if I measure the length of this whole 15 here, that whole length there, that would represent what would go with the 15. So 5 plus 15 is 20. So we are going to put those two together. And again, this 5 becomes irrelevant. And then on the bottom part here, this is a little bit easier. You've got the 12, you got the 16. Those just go together. So all we need to test for is to prove that these have a proportional relationship. So I'm going to put the little divided by the big with each corresponding color. And again, you could have text marked this with circles, squares, and triangles if you wanted to. So I have 18 over 24 is equal to question mark, 15 over 20, which is equal to question mark, and 12 over 16. And so we need to test this and see what happens. And you can see if you divided this, if you put this all in a calculator, 18 divided by 24 is 0.75. 15 divided by 20 is 0.75, and 12 divided by 16 is 0.75. So it does look like it works. Yes, they are similar. And we know they're similar, and it says which theorem, so we'd have to say this is similar by side similarity. Again, for those answers, there's only two other answers you should be able to come up with. Angle similarity or side angle side are the only other two answers you could come up with. So it's going to be one of those three, or it's going to be not similar. So just kind of be mindful of that those are the answers you should be coming up with. All right, that kind of lets you go on to this next page here, which is a lot of the same problems, keep you going so you can get some practice on your own. Let me know if you have any